Welcome to our tutorial of Proflan. In this video, we're going to look at concept to do with motion graphs. F is equals to MA. This is modular kind of questions that have been done in the previous years. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. So let's dive in so that we can be able to see which are the questions that have been tested and what is the best approach you're gonna use in order to answer such kind of questions. All right, so these are the key formulas that you really need to remember whenever you are given a question to do with this topic. So if you are asked average speed, you can see that average speed is given by the formula total distance moved divided by the time taken. If you are told to calculate acceleration, is change in velocity over time, which also can be given as this format here, right? And then if you are given final speed, initial speed relationship, also we can be able to use this particular equation. Force, also the relationship that connect force, mass, and acceleration is given by force is equals to ma. So these are kind of formulas that you really need to understand as far as force motion is concerned. And also don't forget the main equation or the concept of weight, mass, and gravitational field strength are quite important also. Now let's look at what are the kind of questions that have been asked in the previous areas and how are you supposed to approach them in such kind of a scenario. In this way, we are going to look at pale, 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 pale. Okay, so we can be able to proceed and look at the question that has been asked. A car is driven along a straight road, and then now we are told along this straight road what's happened. Which row of the table shows the change in thinking and braking distance when the speed of the car increases? Thinking distance. This is the distance traveled by the car while the driver is thinking. Yeah, so thinking and braking distance, and also thinking distance, I've said that is the distance traveled by the car while the driver is thinking to make a decision on while the driver is trying to judge what he's going to do. And then when we are talking about braking distance, is the distance traveled from when the driver applies the brake to when the car stops. Now, so what are the changes that happens as the speed of the car increases? So if the speed of the car increases, then it means that thinking distance is going to increase, and also braking distance also is going to increase. So what we are going to take here is option A, because if the car is moving very fast while you are just deciding what to do, the car is going to cover a larger distance. And also if you brake, the car will take longer to come to a complete stop. So that is what I'm saying. Thinking distance and also braking distance is going to increase. A truck drives along a horizontal dry road. We are going to graph what happens if the truck has to stop due to the obstacle on the road. The graph shows the speed as varies with time. Okay, draw another line on the graph to show how the speed of the truck will vary when the road has been icy. So if the road becomes icy, When the road become ice, it means that it's going to be slippery, and also friction is going to be less, which means that it's going to take longer for the car to stop. So meaning that if we are going to draw that, we are going to draw a straight line here, and the graph will be like that. Because it's slippery, it's going to take a bit longer for it to stop. The initial kinetic energy of the track is given by this value. The mass of the track is given by this. Calculate the initial speed. So for us to work out this, what we only need to remember is the formula that is used to calculate kinetic energy. So we're going to say kinetic energy is given by the formula I have mv squared. So since we are provided with kinetic energy, then we're going to say this is 6.3 times 10 raised to power 5 is going to be equals to 1/2 times mass, which we are provided as 7.5 times 10 raised to power 3 kgs. And then also we are asked to work out the velocity or the speed, so we are going to say v squared. So which means that I'm going to rearrange this formula and try to make v the subject, and this is going to be v squared is going to be equals to 2 times 6.3 times 10 raised to power 5 divided by 7.5 times 10 raised to power 3. And then for I to work this speed velocity out, I need to find the square root both sides. So which means that our velocity is going to translate to what? So we are going to plug that into the calculator, and you have to ensure that you place everything in the calculator properly. And this is going to be 2 times 6.3 times 10 raised to power 5 divided by 7.5 times 10 raised to power 3. And if you just put it like that, it means our answer becomes 12.96. 12.96 is our answer, meters per second. And since this was given two significant figures, you can see questions were given two significant figures. The raw data was provided in two significant figures, so it means that we need to give our answer in two significance as well. So that is going to be 13 meters per second. Already it's written, so we don't write the units there because already the units were given here. The truck brakes until it stops. Explain why the work done by the braking force is equal to the kinetic energy of the truck before it started to brake. Work done. Why is it that the work done is equal? So this because this is because of the law of conservation of energy. This is because of the law of conservation of energy. So something that we need to appreciate is that the law of conservation of energy applies in that energy cannot be created nor destroyed, but that energy is converted from one form to another. All right, so there is no way energy can be destroyed or created, but the energy is converted from one form to another. It was having kinetic energy, so the moment brakes are applied, it means that kinetic energy is transferred to some other forms of energy such as sound, thermal energy, and so on. Yeah, so because of the law of conservation of energy, so which means that we are going to add a statement there and say kinetic energy of the truck is converted to thermal energy storm, into thermal energy storm. The braking distance for the truck is 14 meters. Calculate the braking force. So in order to work out this, we're going to relate the two. We're going to say work is equals to force times the distance. And we're going to use the concept that the kinetic energy is the one that is equal to the work done. And in that way, if you look at this, the kinetic energy was 6.3 times 10 raised to the power 5. So we can say 0.3 times 10 raised to the power 5 is equals to the force times the distance, which is 14. So in that way, we can divide by 14. We can divide by 14 here. If this and this cancels out, we are going to get our answer as F is equals to what? We are going to substitute that into the calc. So 6.3 times 10 raised to the power 5 divided by 14. That is going to give us 45,000 Newton as the amount of force. So that is the braking force is 45,000 newtons. And which of these describe how energy is transferred by the braking force to stop the truck? Energy is actually transferred mechanically. In this case, energy is transferred mechanically. So we're going to say the best option for this is option A. Energy is transferred mechanically. The table shows the stopping distance of the truck. Stopping distance data for a truck traveling at different speeds. So if the speed is 10, it's 14. If it's 15, it's 27. If the speed is 20, it's 45. So which means that as speed increases, as the traveling speed increases, it means that the distance also increases. Evaluate whether the stopping distance for the truck is directly proportional to speed. So which means that if distance is directly proportional to speed, let me use V, then it means that D is equals to KV. So which means that we introduce the constant of proportionality. So which means that if you take distance of speed, it will be a constant. Now from here, I want to use two data values. I use this distance and this speed. I check the constant I get. Is it the same? So if the constant is going to be the same, then it means that it's directly proportional. So also let's check. When the distance is 14 and speed is 10, let me check what the constant is. 14 divided by 10, basically that is 1.4. Okay, we have 1.4 there. Let's try when the distance is 27 and the speed is 15. Are we going to get the same constant? 27, 15. Let's check. 27 divided by 15. The answer becomes 1.8. You can see the constants are not the same. Let's check when it's 130. So you see 100 divided by 30. If you work it out, you see it's 3.3. So it's not directly proportional. So we're going to say it's not at all, it's not directly proportional. Yeah, but it increases, but it's not directly proportional. Let's look at another question that I've been asked from the previous video. You can be able to check this video here that is showing there. We did distance velocity time graph, but now here, check this link, this video that is showing up here. We did velocity time graph and the kind of question that I asked, but now this one is dealing with distance and time graph. And let's see what question was asked. Using the information, determine the speed of the car. We are finding the speed of the car in the first from 0 to 0.75. How do you get speed when you have a distance time graph? Speed is determined by the gradient. If you work out the gradient of that line from that region where you are being told, you are going to get the speed. So we are going to say speed from distance time graph is going to be equals to the gradient. But from, as I said in the previous video also, that if you are asked what the gradient of the velocity time graph represents, it represents acceleration, and the area under a velocity time graph represents distance traveled. So gradient is usually rise over run, isn't it? So which means that according to the information that is provided here, we are going to work out the gradient from this region to up to this point here. We're going to work out the gradient in this region. So we shall try to find what is our rise. So what is our rise here, guys? So what is our rise? You can see this is 5, 6, 7, 8, 9. This is basically 9 here. So our rise is equals to 9 and our run is equals to 0.75. So which means that we can be able to say gradient is equals to 9 divided by 0.75. And if we can be able to put that into the calculator for us to get the answer, we are going to get our answer as 12 meters per second. So our answer is basically 12 at this given point. And that gives us the answer. Which of these will increase the thinking distance? Thinking distance, we have said, is the distance traveled by the car as the driver tries to think what is the next course of action. So in that way, a car has lower initial speed. This will reduce the thinking distance. The car tire is worn out. This will increase, let me just write here, lower initial. This will reduce thinking distance. Car is worn out is going to increase. No. Yeah, yes. Will increase braking distance because friction will not be sufficient. Friction will not be enough. So in that way, braking distance is going to increase. Drivers consume the alcohol. Yeah, this will take time. The driver will take time to make a judgment. So yeah, this is the correct answer in this case. Road is wet, will increase braking speed. Oh, sorry, braking distance. Yeah, so basically that's which of these energy store increases when the car is braking. What increases is actually the thermal energy store, which means that due to friction, the thermal energy is going to increase. You'll if you go and check the brake pads, you'll feel they are hot because due to friction, the thermal energy is going to increase. A person with a parachute jumps out of a hot air balloon, and then we can see the guy is moving downwards. You can see it's moving at a constant speed because the forces, the length of this air resistance and the weight is equal. So which means the person is moving at a constant speed. Now the weight and air resistance are of equal magnitude. Which of these describe the motion of the person? The person is moving at a constant. The person is moving at a constant speed, and the person is ascertained what we call terminal velocity. A person moves at a constant speed if the two forces are balanced, upward and downward forces are equal, so meaning there's no resultant force. So in that way we can be able to say the person is moving at a constant speed. Weight is a vector quantity. Now you are supposed to state how does it differ from a scalar quantity. So you need to understand that a vector quantity is a quantity that has both size and direction, but a scalar quantity has only size but no direction. So we can say state how vector quantity differ from scalar. So we are going to say vector quantity has both size and direction. Has both size and direction. But if you look at if you look at scalar, so you can say while scalar has only size or magnitude. Yeah, as only size, because magnitude is another word for is synonymous to magnitude. So only size. Yeah, only size. A person then opens the parachute. The person has an average deceleration of this. So we are having this guy decelerating at this rate. And then we are also told that the person has this particular mass of 62. Now, calculate the weight of the person. Calculate the weight of the person. So we know that force is equals to MA. So which means that 62 times 5.6, because the deceleration is basically an acceleration, but which is a negative value. So we're going to say this is 62 times 5.6. If you work it out, you're going to get 347 of, I think I'm just jumping the gun. The question is actually calculate the weight. Weight is equals to mass times gravity, then which is going to be 62 times, I need to check which constant have they provided for us to use as G. G is given as we shall use 9.8 here. Okay, let's use which constant they provide for us to use if you are told to use G. Yeah, they have provided 10. So always check, check in your paper. That is actually page page 3. Yeah, page 3. Check page 3. It's you are always provided which value of G you are going to use, and this is going to be actually 620. Calculate the average air resistance, and yeah, so the average air resistance in that case. Let's check any other information that was given for this question. All right, so let's proceed. Don't know if the camera is on. Okay, now you can see force is equals to MA is going to give us what we call resultant force. So that is exactly what we're going to do first. We are going to go to this question. We work out the resultant force as the person is decelerating, which is going to be 62 times 5.6. So 62 times 5.6, that's going to give us the force, which is the resultant force. 62 times 5.6, that is going to be 347 newtons. Now with 347 newtons, and already we have the weight, then you can see, since the person is going to decelerate, meaning the resultant force is acting upwards. Yeah, because if the person is going to decelerate, it means the air resistance is the one that is greater. So it means air resistance minus weight will give us the resultant force, because the air resistance is acting upward and the weight is acting downward. It means if the person is going to decelerate, it will mean that the resultant force is going to be acting upward to slow this person. So in that way, for us to work out resultant force is going to be air resistance minus weight. And if you can see from the previous section, we have already worked out the weight, which is well seated here, and we have the resultant force, so meaning that we are going to work out resultant the air resistance. So we are going to say air resistance. Let me write it once more. Okay. Equals to air resistance minus weight. All right, so which means that 347, which is our resultant force, is equals to drag. Our air resistance also can be called drag, minus the weight, which is 620. So which means that drag or air resistance is going to be 620 plus 347. And if you add the two, 347, you're going to get 967. 967 as the final answer in that case. Okay, working on the last bit of our question here, the person had initial speed. So now we are going to see how do you use, for instance, if you are asked a question, how do you use these formulas that are here? Let's check. Did they really test these formulas? Let me check whether that is the case. Maybe that could be the formula they were trying to test on that point. So the person had initial speed of 45 meters per second. That is the initial speed, 45 meters per second. And we are going to say this is u. Our initial speed is u. At decelerates at this rate, this is acceleration. The average deceleration person is decelerates to, so meaning that decelerates to this speed is the final speed, and this is acceleration. Now calculate the time taken for that particular change of velocity. So they were not testing the question, they were testing about the use of the formula for acceleration. So acceleration is equals to v minus u over t. So in this case, our acceleration is negative 5.6 is equals to final 6.2 minus initial, which is 45, divided by time, which we don't know. And if I rearrange this, I can multiply t here and divide by 5.6 both sides. So it will be t is equals to 6.2 minus 45 of negative 5.6. So if we work out this, we are going to get 6.2 minus 45 minus 5.6, and if you work it out, you're going to get 6.9 seconds. Yeah, so this becomes the final answer for this. So meaning this is basically 6.9. Well, I believe you've learned something. You've learned how to work out questions to do with motion and motion graphs. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. And also you can be able to share Proflan videos to your friends. See you in the next tutorial.